the issue in space, those of you, who's read Scott Kelly's book, Endurance? So he talks a lot about his problems with CO2. They kept letting the CO2 level creep up, and it gave him headaches. I'm sure it made him less effective, more short-term thinking. That's an easy fix. And frankly, the food, no, you cannot have fresh pasta with salad and salmon, but it's processed, it's sugar heavy. There's all kinds of things they could do to the actual in-flight diet that would probably do a lot more than all of this fancy stuff. I mean, you want the fancy stuff as well, but I would love to see NASA talk more about, it's really boring, this plain healthy living stuff. And I think they'll find it has good results.
Yeah. I agree with you completely, and we are actually looking at foods. Definitely looking at foods, because actually it's not just for your well-being, but you think about the microbiome. I'm sure most people here have heard of the microbiome. You have to have good bacteria, and that comes from fresh foods. And if you don't have fresh foods, everything's packaged and sterilized. You're basically killing the microbiome and that would come from fresh foods, and so that's a major issue we're looking at, actually. Billy?
I have a thing. I think so. Hello? Yeah, good.
Sorry, I need to ask you a question. I usually just turn it over to him and he starts talking. There's no point to cue him, he just starts going. Billy's actually doing some interesting things with devices, and he's actually recently introduced me to something completely groundbreaking. Maybe you could talk a little bit about the butterfly device?
Okay, so by way of introduction, I've been an academic heart surgeon. Hello, hello? Check, check. Here, just stay like that. So for the last 22 years, I've been an academic heart surgeon with a passion for inventing and medical device development. And during that period, I invented some stuff. Some of it turned out to be momentous wastes of my time and other people's money. But some of them actually had an impact and helped a lot of patients. And as a result of that, I've recently transitioned to Johnson & Johnson to lead this new center that we've built in Houston, and it's called the Center for Device Innovation. And Melinda Richter, who's here, helped craft the facility. The idea, my passion has always been replacing technique with technology. You know, being a physician, especially a surgeon, there's a lot of skill and knack involved. We want to reduce that so we can disseminate life-saving technologies. But hearing you talk, I don't practice healthcare, I practice sick care. What you're describing, the idea of making it so these interventions are unnecessary is clearly the way we should double down. But in the event that you develop an illness and need treatment, we've identified that very, very simple devices leveraging the most recent technology has the potential to make all of us empowered to treat disease. As you mentioned, there may be a doctor on there, but doctor is as vague as food. There are all different kinds of doctors and all specialties, and the idea that that individual is going to be able to treat some of the things they need to be able to maintain the health of the crew may be hubris. And you're not going to be able to treat everything, but I think there are some things that happen to healthy people in prolonged travel that a simple intervention can have a dramatic impact, and making that so anybody who's smart and can read a manual can perform that intervention. I think that's aspirational. Now I have to tell one little story that I thought you were going to tell about the kidney stones. Everyone that raised their hands that had a kidney stone had lithotripsy probably, right? That's where they break the stone from outside with ultrasound. Okay, so the thing you're talking about using ultrasound to move the stone is that's a new innovation. Lithotripsy has been around for 20 or 30 years using shock waves to break up an ultrasound in the body. And it was developed by aerospace engineers.
I did not know that.
But here's what happened. The space shuttle is a big tube of pressurized air, and it's in an orbit going 17,500 miles an hour. And if something else in that same orbit but going the opposite direction pinged off the hull, usually a little grain of sand, it was like hitting it with a hammer. It made a loud bang inside the cabin. Since it's pressurized air, Those vibrations would bounce around inside the cabin and the energy couldn't leave until everything in the space shuttle was vibrating a minuscule amount more than it was before the impact. But because the shuttle was shaped sort of oddly, sometimes the shock wave would be focused down and break something. It's like in the Houston airport, that sound dome. You stand under it and you just whisper and you hear your whole whisper come back very loud because of the way it's reflected. The shape of the hull was focusing sound and breaking things. They had a meeting to figure out how to solve that problem, and one of the wives, probably bored listening to the scientists talk about the physics of what was going on, said, why couldn't they use that for something good like breaking kidney stones in the body? True story. So space giveth and space harvests. Yeah, right.
And the butterfly.
And yeah, butterfly network.
Yeah.
So butterfly network, this is the thing she talked about. Ultrasound probes. How many of you have had an ultrasound? Yeah. It uses a special crystal that vibrates at a certain frequency, that sends out ultrasound waves when it vibrates, and then acts as a receiver as those ultrasound waves come back. And by parsing it using a lot of technology, again, developed at Jet Propulsion Laboratories and digital imaging processing, comes up with an image of your baby or your kidney stone or whatever you're looking at. Well, a new company, Butterfly Network, has turned that into a solid state, silicon-based wafer. So now instead of being $10,000, it's $100. They can print 90 of them on a wafer this big. And so now the ultrasound isn't a handheld device hooked to a cord to a computer, it's just a handheld device. In line with what I'm saying about trying to make it replace technology, technique with technology, it uses the camera in a phone, you plug it into the ultrasound transducer, it gives you the image on your phone, and using the camera, it sees how you're holding the transducer relative to the patient and gives you arrows on how to move it to get better data. And then it takes all that and puts it up in the cloud. If that's not an integration of health tech and where we need to go for space medicine, I don't know what is. And that's been incredibly fascinating watching that technology evolve.
Thank you for that. So actually, I wanted, before we go to you, Lee, smart systems that actually guide, even aerospace engineers on how to basically do the diagnosis. In particular, I think I want to come back and talk to you about the watch, because a lot of that data, you're going to generate a lot of data, and obviously, especially with algorithms, and Michael and else will talk about the latest paper that you guys put out with the cardiovascular risk with eye imaging. How useful is that if you don't have an expert to analyze it? And so it is about empowering the user themselves to have the outcomes sort of translated for them. Now, the FDA is never going to allow you to be a doctor when you haven't been trained as a doctor, but it will empower you to say, okay, maybe I should be getting a medical consult on this or not. Be able to give you sort of a check engine light, yes, no, there's a problem or no problem. So I do want to come back and talk to that if you guys can be thinking a little bit about it. But with that, I think I want to let Lee talk. And you mic'd up too, so you're good.
I am mic'd up, but I don't know if I'm on. Am I on? Can you hear me? Okay, great. Good. So one of the great things about health and space is that you don't have to wait 45 minutes to see a doctor, and there's no copay. So there are some benefits, even though you can't get a lot of complicated procedures done. At Seven Wire Ventures, we invest in consumer-focused digital therapeutics and technologies that allow all of us to do the types of things that my colleagues on the panel have said, which is, how can we all live healthier and be better in control of our health? I don't think that any of us want to be patients today, but all of us want to be healthy. And so we look for companies that are providing technology, but more often than not, technology-enabled services that allow individuals to be more in control of their health. Some of the digital therapeutics are from really early-stage companies that have just started with a really wonderful idea, and we provide them with support in terms of taking it forward. Others are ones that we've hatched off of some existing technologies and tried to find a path to make it better. Just by way of one example of that, a company that we hatched now called Livongo Health. I know that some of my panelists are also doing similar things in this area, But when you use a glucometer, if you're an individual with type 1 or type 2 diabetes, most of the time the data when you're testing your blood sugar is trapped inside the device. And most consumers will not take the time to either connect it via Bluetooth and then find a path to share it with their providers. And when the providers get it, they're not necessarily looking at it on a regular basis. But what if every time you tested, that data magically went to the cloud, and there was a guardian angel who was looking over it using pattern matching, machine learning as it may be called, and will alert whoever you decide you want to have alerted, depending on the severity of the change that's occurring in your blood sugar. So it may be you get a message back from your guardian angel that says, you're doing great, your blood sugar is in control, and based on your patterns, things are fine. But if you're heading for a high or a low, a hyper or hypoglycemic event, you might need some coaching, or you might need to really get some intervention. And so a certified diabetes educator could reach out to you, or a care team or family member could be alerted. But all that happens because something you're doing in your workflow as a consumer on an ordinary basis is now being translated and shared in a place where you can get the type of advice that you need. And so when you think about translating that to our astronauts, to be able to do things that allow you to monitor using remote monitoring, there's no reason why that data that's collected there in space with a little bit of latency can't be shared back to Earth, monitored, and now given advice before you have a train wreck, right? Let's watch for things and make sure that you prevent the bad things from happening and to allow people to be better in control of their own health.
Thank you, Lee. That's great. So what I want to talk about now is instead of going to the cloud and having a diabetes educator call you, what about an AI talking to you about it? And and in particular, I want to turn this over a little bit to Mike, because we're not going to be able to call back to Earth, or there may be up to a 40-minute delay back and forth if we're, on the surface of Mars, okay? And so, and a consumer may not be able to get through to a doctor, or there may not be that immediate connection. So, and I'll be honest, I was incredibly skeptical of wearables. A lot of these companies that I actually chose to present to you today are wearable technologies, because I didn't feel like, so what? It's not medically actionable. So what if I walked 10,000 steps? So what if my blood sugar is low? As a consumer, I may not actually understand what that means or how to do anything with it. What should I do with that information? And so it's not until I actually started to see papers like the ones that Mike McConnell was just recently on, where you actually are able to take an image or information from a variety of sources, not necessarily just an ECG, but a variety of different parameters, physiological parameters, and you start to build a story. You start to build something that makes sense for the individual in terms of this is your normal, very different from yours, Lee, I'm sure. And now all of a sudden I stayed up too late, and look, there's something going on here. Your heart rhythm's a little bit off. Something's looking a little bit different. Are you about to get sick, or is there something going on? Do you now have something that you need to is medically actionable that you should maybe speak to an AI? So I want to understand how is this going to empower patients when they have access to information? Is it something that's only going to go to a specialist, or is data from like the ActiWatch or some of these things actually going to put some actionable things into the hands of the consumer?
Am I on, or I'll just go loud?
I'm just doing this. Here you go.
Oh, it sounds like I'm on now? Okay, yeah. Okay, I'll just hold. Is that better? Now it's off. Anyway.
Esther can help you.
It's great that this is a conference about technology,
Great. Yeah, I really love the concept of replacing technique with technology. There are, so many aspects of things that we can do in healthcare, but they have traditionally required on manual dexterity or interpretation.
Right.
And so I think, the example of using photos of the back of your eye to help predict cardiovascular risk. I started with a strong interest in technology and imaging, and cardiac MRI and ultrasound, and it's incredible to see that AI is now automating the whole acquisition of a cardiac MRI scan or the whole acquisition of an ultrasound. It's really powerful. But if you want to disseminate, it's hard to disseminate cardiac MRI. Those are $3 million machines. Ultrasound is now much more, kind of being democratized, but light and photos, and we carry around cameras with us all the time, is something that really can be used much more broadly. So there it was using, this deep learning methodologies from the Google Brain team to look at thousands and train on thousands of images of the back of the eye. And we had, this part was still preliminary, we had a little over 600 of these many thousands of scans where they had a cardiovascular event within the next 5 years. But the AI algorithm was able to predict, similar to kind of the clinical risk scoring that the doc does, that I do in clinic, with this similar risk prediction. So we're optimistic that with getting larger data sets, we might even be able to be a more diagnostic way to do that then you don't need, particularly as you think, again, less resource-intense areas where you're not necessarily going to have the hemoglobin A1C measurement or the, all the whole cholesterol profile. So the concept that, yes, you can do this right now on very big computers, but I think getting back to your wearables, things are already starting to be put on, wearable devices. So, if you go to a LiveCore's website, they'll say they're running a form of a neural net algorithm on the Apple Watch that can then look at your heart rate as it's being collected and then tell you when to get an ECG. And so that concept that, yes, the most sophisticated things can be done in the cloud, but can you, once you have an algorithm, given the increased computational power in your phone or, as these wearable devices, and, Moore's Law keeps going, that the ability to run algorithms, because, yes, some things you'll be able to do in a broader cloud, but yeah, particularly if you're trying to get some actionable information, the ECG is a good example. We don't have a continuous ECG unless you're wearing a patch all the time. So this does require that, put your finger on it to acquire it. But yeah, I think we're in a whole new era here.
Mike, if I can just jump in, using the example I gave a brief while ago, there are now FDA-approved algorithms for dosing medications, in the example I use for diabetes. So literally with the readings that you're getting, you should be able to now start to self-adjust within a range that's been set between you and your doctor, the amount of medication you're taking with the learnings that are coming off of the devices that you're wearing or that you're using on a regular basis.
So we have about 25 minutes left in the panel. We are going to be hearing from 10 companies that are going to give us 1-minute pitches. And then we're going to have like 5-10 minutes to have the panelists can ask the companies questions about them. If there's no questions, we can move on. We can finish our panel discussion afterwards. And then we'll open it up for questions to the audience. Does it sound okay? Is that okay with everybody? Okay, great. So I think what we're going to do is, before I introduce the companies, I want to tell you about a new project. So I don't know if you guys can see this. I'm wearing a chip shirt. It's a very creepy looking monkey. The reason he's creepy looking is because he's actually smart and getting smarter. Talk about AI. And what this says is actually it's a new project that I just funded. So let me just say a couple words about my funding. It's non-dilutive government funding, which is really nice for startup companies. In other words, I don't take a piece of the company when I give them a grant. And we actually have a couple of opportunities that are open right now. We have a solicitation that's open through the Consortium for Innovation in Medicine and Technology, CIMMIT, which is run out of MGH. We have 2 calls for proposals right now, and one is for point-of-care diagnostics, so lab on a chip. We have to be able to do blood work in space. We can't do it. And the other is for essentially what we're calling a pocket doctor. So a smart algorithm that can actually walk you through a triaging okay, I've got a pain in my side, or my stomach hurts, or my back hurts, walk you through what a doctor would do in a simple triage situation, because we are going to have aerospace engineers with ailments, and so we need an AI to help them with that. So those two opportunities are open. We'll also have a solicitation that's going to come out this Friday. We also, on our website, so if you just Google Space Health, you'll find us. But we actually listed the topics that we're going to be soliciting for shortly, and so that's free money. Take a look at that, the opportunities. But this project I wanted to tell you about is a new one that we just funded. We want to be able to source innovation in a new way that, again, having a smart AI do it for us rather than me having to go to 1,000 conferences like this in order to meet with all these wonderful companies. Have the AI do the matching for me to customize my search. And we're inviting partners to join us. So there's the pediatric hospitals are very interested in sourcing innovation because it turns out that children is actually not a big enough market for a lot of people to invest in, and so they're sourcing their own innovation, so they're partnering with us on this. But it's essentially a platform where companies get matched up with people who have money, like investors, or an organization like mine, or government agencies, et cetera. And so CHIP is actually something that we're going to release tomorrow. We're going to have a press release tomorrow. And that's how I found these guys right here, these companies. And so you're going to hear from them. And so I just wanted to tee up the project and let you all know, and you're all welcome to be part of it. You can find it on the website, personalizedinnovation.health. And with that, I think we will move into the 9 really very interesting companies. So let's see. So we're ready to go and hand them the mic. Is that how this is going to work?
That's correct. It's going to be a minute.
Okay. So
We've got the gong.
There's a clock for you.
Cosinos from Germany, Greta Cruiser. She came all the way from Germany. So, all right, give her a big hand. Thanks.
Well, it's Kreuzer in German, but thanks. A Sage to your health, that's what we provide people with this device. It's a wearable sensor, surprise, that sits inside the ear canal, in the outer ear canal, and is able to continuously monitor heart rate variability, core body temperature, blood oxygen saturation, and in combination with an ECG chest strap, also blood pressure. And you can use it in everyday life. And besides these vitals, we can see parameters like breath rate, 3D acceleration of your head, steps, step frequency, and we are able to integrate fun functionalities like audio feedback, audio assistance, music, telephony. Yes, and our vision is to empower people, empower you to get access to your data, to gain insights into your health. Thank you.
Perfect, look at that. I'm going to say something politically incorrect, but the Germans are always on time, so that was great. Next, we have Tom Hayhurst from iAssay. Oops, come around this way. Yeah.
Hey, good morning. iAssay was developed as a company with a disruptive technology to address the dilemma and the impasse that has been facing consumers as well as providers in the point-of-care testing market for over 2 decades, and that is menu. We have 129 different CLIA tests that are approved for blood testing and or urine or other body fluids. The problem is there is no one instrument that has all of the tests that are necessary, especially for those that are the astronauts going to Mars. So with this device, through adapters, we can take any one of those tests that you can have a body fluid, that you can pick up a reading, whether it be electronic, whether it be magnetic, or any other type of reading from urine, from blood, or from a buccal cheek swab in order to get that reading, all on one instrument. It's the size of your hand and can be used on the power and simplicity of a cell phone.
Perfect.
Very cool.
And the American is on time. Yay.
Tricorder.
It's the Olympics of keeping on time here. Okay, next we have Mike Strasser from Motive Inc.
Howdy. So when you think about what's needed for space, you think about minimal, you think about robust, also as well as something that you can go out to space with and it has a very reduced consumables. You can't have something that requires AA batteries. And also when you think about the story of even the ultrasound, we kind of think of things like a big box that's going to be able to image your body, but then there's new technologies come out that make it into something the size of this microphone. And so even my classmate at Stanford, he invented wearable technology back in the day, and it was a tool belt with a bunch of computers on it, with a hard drive and everything else. But again, you kind of assume that maybe wearables is a tool belt. But today I'd like to share with you guys the Motive Ring. We're basically taking technology. We actually do neural nets, algorithms, heart rate, acceleration, so we can do activity detection, all in the form of a ring. So something that an astronaut can easily wear when they're in space, and us humans down on Earth can also get the same benefit of understanding the biomarkers of the body and being able to give that back to the user.
Very cool.
Can we get that bedazzled? Just wondering. Okay, next we have Francois Gand from Neuro. Canada.
Good morning. There are millions of individuals that have had their lives shattered, either because of a sudden accident or an unfortunate illness. Many of them have inability to communicate either with their family members or with their doctors. Neuro aims to change this. We have developed a neural operating system called NUOS. It allows any individuals of any age or any ability or lack thereof to communicate and fully compute using live neurological signals. The architecture is a mix of hardware, software, and adaptive deep learning. It allows those people to reach a sense of normality. Our main interest at this point in time is in various areas of healthcare, from acute care to palliative care to rehabilitation. And we also have received several other interests, such as launch transportation ventures or oil exploration. We believe that we can bring NUOS to space to allow astronauts to have neurologically powered interactions in terms of communication, vehicle monitoring and control, as well as habitat or robotics. We thank you very much for allowing us to be here, and if you wish you talk to me afterwards, I will be here, and you can look us up at neuro.ca. Thank you.
You can hold it up.
So you probably really don't understand how this works, so you get a chance to ask him a question. It's actually very interesting, so maybe later you guys can figure it out what exactly this company does. And so with that, I'll go to Krishna. I know I'm going to screw up your Bhargava. Okay, Real Lab, and you didn't go to bed last night, so.
No, I had a meeting with the UAE, unfortunately.
Oh my gosh, so I'm impressed. You look very awake.
I don't do a lot of sleeping. Compliments of working medicine, yes. So we're Real Lab, and clinicians oftentimes depend on high-resolution quantitative lab data in order to effectively manage acute and chronic conditions. Unfortunately, this takes a day or two coming out of a central or a hospital lab to return those results, which causes a lot of patient over-management and sometimes under-management. Our technology can do more than 30,000 different protein-based diagnostic tests available across labs today, but we can do it in minutes, right there at the point of care. And that's because at the heart of our systems, we have complex 3D printed microfluidic devices like this one. Now, these systems are a lot like a computer. They reconfigure on the fly to process all kinds of sophisticated diagnostic tests. Space being kind of the lowest resource setting that you can think of course means that you need to empower astronauts with the sort of capabilities you would find in a central lab. So we can effectively give astronauts that capability in a device the size of a shoebox, and about as easy to use as a Curie copy.
Thank you. So you all need to come and look at this thing because you can't, this is pretty incredible, so come take a look at it when you have a chance.
This is not your 3D printing for toys.
Yeah, this is very cool. Okay, and I'm so sorry, Lenny, I skipped you. Neurosteer, Lenny Rydell. And so we have Germany, Canada, and now we have Israel. So here we go.
Tov me'od.
So imagine if you can take a functional MRI into a sticker-sized form factor, that it can provide you really a great ability to interpret and access the brain, basically, which is a very important function. You cannot function without the brain, right? So what we are doing, basically, we are taking very advanced signal processing, and we are trying to use it in order to extract very simple biomarkers in a way that astronauts or anyone can look into a single figure and say, okay, I'm okay on my cognitive side, or I'm stressed, or I'm not sleeping well. So basically what we are trying to do is to provide any of this information to anyone who is able to put a sticker on his forehead. Basically, this is it. And if you can put it, then you can take it, everywhere, including Mars, I think.
Very good. Thank you.
Very cool.
Next, we have Milo Life, Russell Lee.
Right.
Lab diagnosis available anytime and anywhere. We've created a suite of micro devices, compact devices like this, each with the FDA-cleared rapid result microfluid test using blood, urine, or saliva. Each device is embedded with a patent-pending smart ecosystem that wirelessly transmits the result to your smartphone, to our Milo app, and then you can transmit that to your doctor if you choose to. The system monitors pretty much every diagnostic that you would ordinarily do in a lab. For example, PSA, cardiac markers, most all conditions like high cholesterol. And it's a home device. Basically, 13 billion tests that are performed in labs every year. It's designed to improve the economic and clinical outcomes for patients. It's designed to be covered by insurance and increase the return on investment for doctors who are referring and writing scripts for the product. On any frontier or on remote places on Earth, this device is so suited for its robustness, its microfluid, and rapid result.
Thank you. Next, we have Jackie Laver, okay, with eHealth Analytics.
Well, the problem we're solving here on Earth relates to the alarming increase in medical device adverse events and recalls, costing the device industry, patients and payers billions of dollars a year. More importantly, putting those patients at severe risk of losing their health, their lives. And our predictive analytics will determine the best combination of procedures, devices, medications, and lifestyle changes to produce the best outcomes in the most complex scenarios. The interaction of these devices in conjunction with all other medical factors is not something that's ever been done before. And our cognitive models will rapidly and constantly process massive volumes of data, including data streaming from the devices that the astronauts are using. I think I lost it. Okay. Using 4 years of data from the FDA, our prototype produced a 98.5% accuracy rate in predicting which devices would eventually be recalled. And that will aid in the selection of devices prior to launch. Thank you very much, and I want data from all of your devices. Thank you.
And last but not least, we have, actually you're here from Austin, but you're now in Houston. Irene Brinker from Suns 10.
Thank you. So initially, we were contacted by NASA Challenge, the wearables challenge. They were looking for a way to read non-invasive blood pressure, and we had to respond with, well, we've got one up on you. We could read constant non-invasive blood pressure. In fact, here's a working prototype, and this is based off of constant electrocardiogram that does not require a second hand. Currently already launched and live and delivering to 2,000 customers based off of our crowdfunding. So what we have is a combination of sensors, our patent pending ECG monitor for one hand that does not require a second hand. We have our constant blood pressure monitor built on top of that, blood oxygen saturation. We're reading heart rate variability, and we are currently looking into a couple of sources to also have core body temperature included, as well as our remote monitoring platform that can also provide risk assessment. Right now it's cloud-based. But we are SenseTech, and I would love to talk to all of you further about this. Thank you.
So we're actually running a little behind schedule. I saw a lot of folks take notes up here about your companies, so I think if there's specific questions, we'll go ahead and have them speak to you afterwards, if you can hang out a little bit. I think what I'd like to do now is give the audience an opportunity to ask questions to our panelists. So there's a mic right here. Anybody want to ask questions?
Hi, this is a question for a couple of the presenters, I guess, at the end. My name is Josh. I'm a critical care physician. One of the things I follow a lot is measurement of non-invasive. My name is Josh. I'm a critical care physician. And one of the things that I follow a lot is the non-invasive measurement of blood pressure. So I guess if there's any presenters who are able to talk a little bit about the mechanisms of how they detect blood pressure using, I guess, non-compression based devices and perhaps the validity of those tests. Thanks.
Perfect. I'll actually introduce you guys to our brand new Chief Medical Officer, Dr. Alexander Kuk, to take that question.
Thank you. So let me reply to your question. The way that we approached this problem is that most of the devices right now that are trying to measure blood pressure, they're using two PPG sensors, the optical sensors, just to try to figure out the speed of the pulse wave that is coming through one sensor and the other one. This is the nice development in general, although it has a lot of limitations, because it's using like a distant, sensors applied on the limb, one limb. And the ECG sensor that we have developed, we have introduced the third point of measuring the distance of, and the third point of measuring the speed of the pulse waves originating from the heart when the heart contracts, and then measuring on the limb. So that's the way we approach that. And that's the way we made it more sustainable, more precise.
Okay, so I would like to ask a question of all the panelists with devices, and the answer should be max 3 words. How do you charge it, and how long between charges?
Yeah, we are charging it via USB, a micro USB connect.
Okay, how long?
Connection, and it takes 8 to 10 hours.
Great. 3 words. Go ahead.
How long does it last?
I'm sorry?
How long does it
8
last?
to 10 hours.
8 to 10.
And how long does it take to charge?
Oh, one hour to charge.
Okay, thank you.
This is same as a cell phone, and it's only being used, it's
Okay,
using
great.
electricity.
3 words. We're
Intermittent use.
Little USB connector, and it's on like that, and it's 90 minutes for 3.5 days.
3.5 days.
So far, we have different chipset and module, but 8 to 16 hours in total.
Micro USB, 90 minutes, 20 hours for operating.
Ours is a wall adapter based system meant for triage, but in a astronaut setting, this would easily run off of a 9-volt battery.
Ours is battery, use it 15 to 20 times, throw it away. Reusable strips, which you can use with new devices. In space, we have a rechargeable version you can plug into a cell phone. We have which we're using for glucose and
No battery.
No batteries needed.
So the consumer device, 90-minute charging, 48-hour battery life. And that's a little magnetic charger. But the medical one with the 4 vital signs, that has a mini USB right now, although that's still in development. And that battery currently lasts 48 hours.
Perfect. Thank you. Any last word or questions from the audience? Because I'm going to give our panelists an opportunity to make some concluding remarks. Questions? Okay. So with that, I'm going to start with Lee over here. Lee, you want to impart any wisdom?
So what I would say is for all of you who are on the device space, I know maybe 8 out of 9, that distribution is key. And so finding the right partners to work with in terms of being able to get broad market adoption should be one of the key focus points for your business team.
Show of hands, who here has a wearable on or usually wears a wearable? Okay, and you realize you're an incredibly skewed population. You came to South by Southwest, you woke up for a 9:30 talk. This front row couldn't be more skewed. I think the success of wearables is predicated on the success of being able to take people and from an early age teach them to take control of their health and show that it does make a difference. Some of these things, metrics that you guys are capturing, I'll say I don't think make a difference. As a physician, if somebody came into my office and said, here's all my blood pressure readings every day but for drug trials and this white coat hypertension, that's what we call it. How do we know they don't get hypertensive every time it's their turn at the grocery line? That'd be very valuable data when you're changing medication, so I believe in that. But I think we've got a long way to go before we can create any value with this data, and it's going to be getting people to take control of their health, to capture, to correlate it with results, and then make it important.
But you also need to make it easy for them, and things like charging really matter a lot. I remember 20, 30 years ago crawling around hotel rooms looking for the modem outlet and knowing that in 10 years it would be better, and it was so frustrating. It's the same with these devices, and until they are easy to charge, they last a long time, you can tell your time on your watch without. So all of you, honestly, I feel like it's the tricorder all over again, and I couldn't really tell most of them apart. So your challenge is to have people like us that you can talk to for a minute understand why yours is different.
Wait, do I get the last word, or I'll pass it back? Yeah, so ours takes about an hour and it lasts for a week. So that was actually one of our key learnings from the first, generation device, was really to make it. You didn't want all these failure points to be too easy. But I think what I'm super encouraged about, and we've heard a lot here today, and I think space is a great example of where really making the patient or the consumer or the person the center of the data, and the ability to look at the data and to encourage behavior modification on top of that. And so that's a key factor, not only the behavior factors of the basic wearability and chargeability, but clearly the data shows that the more that you incorporate behavior change science in your product, then the actual impact on improving diabetes and other measures like that has clearly been shown. So strongly encourage you to make sure you have kind of user experience, behavior science folks as part of your program, because that's going to be key to having actual impact.
And if anyone in the audience has an Aura Ring charger, please come see me. I speak from experience.
She left it in New Jersey.
Yeah.
Well, that was a perfect last word there.